Okay, hello everyone. Today we will be doing the Canadian Math Kangaroo contest problem from grade 11 to grade 12, and this is a video series where we explain each problem. And let's begin. So the first problem, we got a expression and we want to know what is the value of this. Well, it is very simple that you just take out the factor of 11 to the power of 2 and you cancel that out and simplify what is left. You got 49 over 10. And question 2, somebody rolls 5 dice. The sum of the rolled faces is 19. What is the maximum number of 6? So what happens if we roll 3 different 6 is that we have one more spot for the 2 dice, which is impossible because we know that each dice has at least a value of 1, which is at least going to be 20, so that's not possible. So it must be 2. And question 3, the cylinders. So by looking at this picture, we know that it just traveled 2 circumference, and the height it traveled is the sum of the cylinder height. So it's going to be 15. And 2 circumference plus the height, we got 75. Question 4, there's 4 different color of crayons. And we need to determine the way of painting it without any adjacent color to be the same. So suppose we use only 2 color. We paint from the top to the bottom. First we use the first color and then we use the second one, and then we alternate back to the first color, or we can just start with a new color, which is the third color. And 4 times 3 is the number of ways in which you can pick the ways to paint in the first combination. Because first, when you choose the first color, there are 4 different options, and when you're choosing the second color, because you have already taken out of one color from the 4 different color, this leaves you with 3 different options. And when you are picking the third color, because you know you already taken 2 colors, there's only 2 options left. You multiply that by 2 and you got 36 to be your answer. And how many positive integers have exactly 3 distinct divisors? Well, obviously it's the number 4, and which means there's only one possible integer there for us to choose from. Okay? Because just recall that the number of divisor of a certain number is, after we obtain its prime number decomposition form, E1, E2 all the way to the EK is going to be the power of each prime, and this is going to be the number of divisors. Okay. Question 6. How many positive integer roots does the equation of this have? So first notice that we got 3 different equalities. So everything under each square root has to be positive, and the overall square root has to be positive. So this thing is greater than 0, and we know that the absolute value of this is greater or equals to the root 45, which indicates that the absolute value of x is greater or equal to 7, because x must be equal to an integer. And from this, we get the absolute value must be less than or equal to 7, because this thing here, and this thing here, they are both positive. So x plus 4 minus 4 must be positive too, which means x is positive number, which indicates that x could only be 7. So there's only one integer rule, which is 7. So we pick B. Next page. Okay, so question 7. How many positive integer pair xy satisfy this equation? So we rewrite this as x equals to 2 to the power of 10 minus 2 times y. And we know that both x and y, they are greater than 0. So x equals to this thing. So this thing must be greater than 0, which indicates that y is going to be less than 2 to the power of 9 because we just move 2y to the other side and divide both sides by 2. And combine those, we get a total of 2 to the power 9 minus 1 number. And question 8. So two equilateral triangles are overlapped to form a hexagon with their opposite side parallel. So this is parallel. And notice that this is an equilateral triangle, and the side of this equilateral triangle is going to be 6. Okay, those are the same. 6 plus 15, and those two sides are the same, and plus 11. So consider that both sides of equilateral triangle is going to be 32, and this thing is 32. We subtract this 6 here, which is going to be 26. So the sum of this part is going to be 26, and we move this part to here. So this part plus this part is going to be 26. Notice that, and no, we don't need to make any observations. So 6 plus 12, because this thing is 26, right? So 2 times 26, because there's also a 26 here. So the answer is going to be 70. Question 9 here, we need to fill in the blank from 1 to 9. So we just need to take a look at the remainder of when those numbers divided by 3. Notice that for each position, the remainder is actually already decided. For example, starting from this one, we need to balance it with a remainder of 2 to make the sum is divisible by 3. And next we solve this 0, and yeah, we just can keep going this. We can just make it keep going. So that's the final result. So there's a total of 2 different ways to assign those ones. Those 2 numbers are already fixed. And to pick this position, we have 2 options, which is 1 and 4. And we use the other one to fill out this one. And for those 3 remainder of 2s, the first one we have 3 different options, and then 2 options, and then 1 option. So 3 factorials. And similarly, for those zeros, we have 2 options, and we multiply those together, we have 24, which is equals to E. And question 10. So this is just okay. So this is just a geometric series. So this is the area of first dark square, and this is going to be the second one, and so on, each with a rise of power by 1 of the 1/4. Okay, and this is the formula, and we calculate the sum, each equals to 28. Question 11. So this diagram is kind of sucks. So yeah, this is how it should be looks like. This dashed line is behind. We cannot see it, and this one should be a solid line, which is at the front. And we need to figure out the sum of those 2 sides. Notice that we have integer length mentioned by the problem. So because we know that for any given side, we cannot have that greater than the sum of the other two sides, which is the fundamental rule for the triangle forming. So we have two different systems of equations, and we can solve the value of this side length and this side length. Because, for example, A, this side, and we have a triangle here, and this A cannot be greater than 3 plus 4. And notice that in this triangle, okay, 2 plus A cannot be less than 7. It must be greater. This is the fundamental rule for the triangle to form, and we have the value of A and B, and A plus B equals to 11. We can just use the similar technique to solve for B, okay? And question 12. Okay, so we can rewrite the 6 factorial equals to 8 times 9 times 10, okay? And then we multiply 7 factorial, and that equals to 10 factorial. And the sum of the digit of this equals to 1 plus 0 equals to 1. So we pick A. Okay, question 13. So we try to, okay, there's a specific point that doesn't matter the value of A. So we're just trying to get rid of the value of A by manipulating the value of X. Suppose X equals to -2, okay? And we just cancel that out. And we sub in -2 to the equation. And we find that it is always, the Y value is always equal to 8. The question is a little tricky. It's the sum of the coordinate. So we plus the X value, which is equal to -2, and the plus 8, which is equal to Y value. So that's going to be 6, which corresponding to E. And question 14. This one is kind of interesting. When you're pressing a button, increase the number of the fraction part, the decimal part, okay? And this question, so our goal is to reach 10. And the 10 could only be obtained by the previous number, 9.5, and press once the button. And 9.5 could either be obtained by 9.25 or from the previous number than 9, which is 8. And it has like across a specific integer. And we just keep building our tree here. And we got 1, 2, 3, 4, 5, 6, 7, 8, a total of 8 values. Notice that he says, what did he say? Okay, he said less than 4 times. So from 0 to 3 times could be the number of times we press the button. So don't forget to include this 10 over here. So how many pairs of this satisfy the inequality? So notice that m has to be an integer, and this thing here, doesn't matter how well you are picking the value of m, it's always going to be equal to 1. And it has m equals to 1011 and 1012. And then this thing must be equal to 0. So this is obviously an even number. So in order to make this equal 0, m has to be even. So this gives us a single value of m and a corresponding value of n. So there's only one pair, which is equal to b. Question 16. Okay, so this one is kind of interesting. So the optimal way is to construct the string is like this, because we are making sure that for each seat, it doesn't matter which animal it is, there must be a kangaroo. So not only that the beaver must have a kangaroo to be a neighbor, the kangaroo must also have a kangaroo to be a neighbor. So yeah, so this one is quite optimal because this kangaroo covers this seed and this seed. This kangaroo covers this seed and this seed. And so on. Like this one is kind of inevitable. Like we have to, we have to do this. We are only use for each seed. It's exactly covered by one kangaroo. So yeah, there's a total of 11 beavers out there, and we already minimized the number of kangaroos, so D is going to be our answer. And question 17. So the smallest positive integer over this interval contains at least 4 natural numbers. So in order for the range to come across four different natural number or integer, we must have the difference of this interval to be greater or equal to 3, because this is the optimal or most ideal situation. So this is an integer, this is another, and another, and the distance here is 1, 1, 1, 3, okay? And by subtracting this, the right boundary by the left boundary, we have 3. And we solve that m is greater or equals to 15. And we find that this range is actually having 4 different integers. Therefore, the minimum number of n is equals to 14. So yeah, so that's none of the above choice. So the answer is E. And question 18. So we need to know that which edge corresponding to each edge, and you're kind of testing your imagination skill. So I draw a bunch of arrows to help you understand that which edge are together and how they interact with each other. Hopefully that helps a little bit. So A doesn't work because, okay, you know what? Let's label this. 3, 4, 5, 6. So 2 and 3, those two, they are not kind of connected. So B, because look at our arrow here. So 1 and 6, they are not connected. So C, let's take a look. So 1 and 5, see, they are not kind of connected because there are 2 different lines here and there's only 1. That means the one line is not going to be connected. So E is not correct because this edge and this edge, they cannot connect together. So D must be the correct answer. Question 19. So notice that the area ratio of this is 1/3, and this triangle and this triangle here, they share the same height but a different base. So we know that the base ratio is 1:3. So notice that this triangle and this triangle, they share the same height but different base. But we use those 2 triangles to determine the ratio of this base to this base is 1:3. So this area must be 2 times 3 equal to 6. Similarly, using our base ratio technique, we can get 10. So 6 plus 10 equals to 16. So equals to C. Okay, question 20. So question 20. So notice for any how many integers are a factor of this but not a factor of this? So in order to be a factor of this, we must have both of those conditions to be true, and in order to not be to be the factor of this. So So at least one of those rules must be violated. So, this is the number of ways that number rules are being violated while this condition is being satisfied. And this is the number is the rule number 2 is being violated and while this condition is being satisfied. And since those two together count the cases where both of them being violated exactly twice. But we only want to count each case exactly once. So we overcounted by once, so we subtract this by once. So that gives us exactly 1 or 2 or both of them being violated, and we get the answer 273, okay? And question 21. Okay. So the first thing first is to determine the angle of those. And using the angle formula, so there's 8 sides, right? 8 minus 2 equals to 6. And we times 6 by 180. That's the sum of all the internal angle. And there's 8 angles in total. And we divide that by 8. That's the degree of each angle. And we want to determine the angle of this. We have 135 divided by 90, which is, and then we divide it by 2, we have 22.5. So, using the cos 2x formula, here we can get a value of cos 22.5 and the cos 20 and sine 22.5 by assuming that x equals to 22.5 here, and we already know the value of cos 45 and the cos 45, and we just put the 1 to the other side and we divide it by 2 and we take the square root. And similarly, to get the sine 22.5, we just put this to the other side, put this to this side, and divide it by 2 and take the square root. To get the tan 22.5, we have sine 22.5 divided by cos 22.5, and we, after a bit of annoying simplification, we get root 2 minus 1. And we know that the area of this circle here, and we take the square root and divide it by 2, we get the length of this to be root 2 over 2. And we use our tangent 22.5, we get the size of this. Notice that this thing is going to form a rectangle if we move this part to this part, okay? And there's exactly 4 different rectangles, and we add the size of the square inside. 2 times 4 of those annoying rectangles, and which is equal to 2 root 2, okay? And question 22. So there's 13 climbers, and the score of this, the higher the score, the lower of your ranking. So first we want to maximize the score of this girl. I don't know her name, so it's 13 because we know that she get first in the first 2. She may be doing the horrible in the last one, so 13 is going to be the worst case scenario, and then we try to optimize the score of the other 2 guys. We find that we try to accommodate like as many of the contestants to be good score as possible. Like suppose we want to have 3 different contestants that have a better score than her, but we try to minimize it because we know that we must use up 2, 3, 4 if there's 3 people that's ahead of her, because look at this, so she get the first place, right? In order for those guys to be in front, there's people to get second, third, and fourth, right? We try to minimize our score of the other 3 guys. So here, like, no matter how we minimize this, 1, 2, 3, it's going to be too big. It's not possible. So yeah, there's only going to be 2 people that have the better ranking of her. So the worst case scenario is she is going to be 3rd place. Okay, question 23. This one is annoying. So we try to determine the value of each corner, and suppose like we observe there's a pattern here: 1, 1, 2, 2, 3, and 3, 4, and 4, and so on. So the corner value is going to be 1 plus 2 plus 4 plus 6. Okay, from the top right to bottom left, and then again to the top right, and so on. That's how the pattern looks like. So we know that this K is going to be odd, and this value 651 is going to be the value of top right, because suppose this K equals to odd, even, odd, even, odd, even, top right, bottom left, top right, bottom left. It's just like matching this pattern. So we sub in K equals to 25, this is the value we got. K equals 24, this is the value we got. And this is the value of bottom left, and then we plus 25, that's going to be our top left. And 626 is going to be our top left. And this matches this pattern here, so the answer is going to be B. Question 24. Okay, so we are flipping this tetrahedron. So after the first flippings, the shade side is facing this way. So imagine each flip is kind of like a symmetrical axis, because I was originally facing this side, and after this flipping I must be facing that side, and so on, until I now face this side here, and I flip. I'm back to the bottom here at the section E. So the answer is E. Question 25. This one is not a lot to say. So when you're expanding x minus 1 to the power of 5, you're gonna find a constant is going to be -1, which is not equal to -7. So it cannot pick E. So when you expand the x minus 1 to the power of 4, and when you try to multiply this by x minus 7 to make the constant equals to -7, and we find that it just works. So the answer is equal to D. And 26 is a very simple problem. So suppose the radius of this circle is equal to x, and here is another x, and this is x, and this is equal to 8. So this rectangle has a length of 2x plus 8, and since we have this to be a big square, and those 4 side lengths must be equal to exactly half of this big side length. Therefore, so this equals to x plus 4, this is equal to x plus 4, this is equal to x plus 4. So we know this is the radius. It is equals to x. X plus 4 minus 6. So this is x minus 2. So x plus 4 minus x, this is equals to 4. And we use the damn Pythagorean here. And we get this equation, and we just solve for this. This is equals to x equals to 5. So 27. So what is the greatest common divisor of all numbers in form of this? So we know that there must be a multiple of 5 and 3 amount of n plus 1, n plus 2, n plus 3, and n plus 4. And there must be a multiple of 4 inside because those 5 numbers are consecutive. So it doesn't matter which position is that multiple of 4. And there will always be at least one position in which there's a multiple of 2 along with it. Suppose this is 4. And we know that this number must be multiple of 2. Suppose this one, those 2 are multiple of 2. Suppose this one is multiple of 4. This one is going to be multiple of 2. Suppose this one is multiple of 4. These two numbers are multiple of 2, okay? See? It always works. So the greatest common divisor must be equals to this, okay? 2 times 4 times 3 times 5. Which corresponding to the answer E. And question 28. So it doesn't matter what is our middle number. Suppose this, we have 6 and 4. Since this sector here and this sector here, they have the same sum together. And they both share x. So this add together and this add together must be equal. Suppose this is sum number A. This must be A plus 2. And similar technique here. And it doesn't matter the value of x. Those two added must be equals to the sum of those two. Suppose this is sum number of b. This must be equal to b plus 2. And similarly, we get c and c plus 2. And we know that from the original question, c plus 2 equals to 11. And we solve c equals to 9. So this position must be equals to 9. So we pick E. And question 29. So define f of 2n equals to the number of ways to assign 2n student. And this is going to be the formula to group of 2. Okay, this is going to be the formula. Suppose we have 6 students, right? And we give each one of them a label 1, 2, 3, 4, 5, 6. And suppose any permutation, let's say this one, okay? And we divide them into group of 2. So for each group, we can switch the number inside like this. And we can switch any 2 students inside any group. So 4, 3, 5, 6, like we don't switch. Like it's just the same, you know, that's the same result of pairing. It doesn't matter which student goes in front. And we can also switch the actual group itself like this. See, it's still the same pairing. So we can organize those groups in n factorial, and we have option to switch those students inside each group by 2 to the power of n, you see? And there's a total of 2n factorial permutation of distributing number from 1 to 2n, okay? And this is also another easy Venn diagram. So the total number of ways, and AB together, WZ together, and AB and WZ together. Okay, that's going to be our calculation and answer, okay? And let's head to the last question. Question 30. So Okay, this is very interesting. So we immediately notice that this is a 12-digit number, which implies that this product here must have a minimum and a maximum. So this product is going to be greater than 10 to the power of 12, but less than 10 to the power of 13, which gives x a minimum bound and a maximum bound here. And next, let's see how we can optimize this. So notice that those are 6 consecutive numbers, which means that there must be a multiple of 2 and a multiple of 5. So the last digit here, b, must be equals to 0, because the number must be equal to multiple of 10. Okay, and we know that b equals to 0. We know that a, b, c, d, they're kind of consecutive in some way, and we can optimize it by determining that the maximum of a is equal to b plus c equals to 3. And so we get an updated range of fn, the product, okay? And we update the range of n, 66 to 82. Since there's 2 trailing of b, which is 2 trailing 0, then that means that the number must be equal to a multiple of 100. So we only test the range that contains the factor of 5 to the power of 2, okay? And we keep narrowing down our range. So we test this range because this range contains the number 75, which is a multiple of 25, and we don't want this range to contain any other multiple of 5, and we get our result for fn74. This range equals to this number, which has the desired integer form we want. So d corresponding to the number 3 inside this big ugly number. So we pick C, okay? And thanks for watching, and see you in the next one. Goodbye.